Hello and welcome to another quick tip session from SI Imaging. In today's session, we're going to focus on a question that I get all the time. And it's this: what units should I use to quantify the bioluminescent signals in my images? And more specifically, should I use mean radians, max radians, or total photons per second? Now, the short answer is you want to use total photons per second. The rest of this quick tip session is going to be devoted towards demonstrating empirically why, in fact, this is the answer, that you want to use total photons per second whenever you are quantifying your bioluminescent signals in your optical images. All right, so now by way of an example dataset, we're going to use this image of 5 mice that have been previously orthotopically challenged with a glioblastoma cell line that expresses luciferase and therefore will bioluminesce upon the injection of substrate luciferin. And we can see at this time point that the number of glioblastoma cells present in these mice is adequate to generate a detectable bioluminescent signal. So let's go ahead and do an analysis of the quantity of signal that we're seeing. Now, in Aura, which is the software platform that we use in SI Imaging to do signal analysis, we can go down to Toolbox and select any one of these region of interest drawing tools, ROI drawing tools. And I'm going to use the elliptical ROI given the shape of the glioblastoma signal, and we'll draw a circular ROI around the region of the center mouse. I'm just going to keep it to the center mouse now by way of a proof of concept discussion. And what you can see is that there's a label that is applied to this region of interest, designating a number and as in 1, 2, 3, and then a quantitative evaluation of the signal seen within the ROI. And this is given in terms of total photons per second. Okay, now if we want to see max radians and mean radians, we can also go down to Toolbox and Measurement and click the ruler icon, and you very nicely see a summary of those values here as well. Now, the use of max radians can be very easily discounted as follows. Max radians is simply a pixel quantitative designation for the hottest pixel within the region of interest. It is not an overall quantitation of the signal within the region of interest. It is simply telling you how hot the hottest pixel is in terms of photons per second per centimeter squared per steradian. Okay, so this is inherently not going to be a useful regional analysis of the total quantity of signal seen in that region. So we'll discount the use of max rads on that basis. Now, mean radians, given here, is something that you may want to consider as a unit of quantitation for the signal seen in the region of interest. What we're going to do next is show how mean radians is susceptible to various empirical limitations. Okay, so let's say in a scenario we have an investigator that uses an elliptical ROI to do their analysis, and they have a colleague that happens to go ahead and use rectangular ROIs to do their analyses, and they're in the same lab and they're doing their images side by side. And so this is how investigator 2 would go ahead and draw their ROI. Now, is this really relevant? Is this going to affect the total photons per second value for that signal, the way it's investigated by investigator 1 versus investigator 2? Will we see a difference? Well, let's just take a quick look. The total signal, the total photons per second seen within the circular ROI versus the square ROI are 1.78 times 10 to the 7th versus 1.80 times 10 to the 7th. Okay, a very minor shift, 0.02 in total photons per second. And the same can be seen in all three images here. Now, the use of these two different ROIs, does that affect mean radian values? Well, let's take a look. We'll go down to Toolbox and Measurement again. And what we can see is that when we look at ROIs 1 and 2, we can just focus on image 1 for the moment, we go from 1.31 times 10 to the 5th to 8.49 times 10 to the 4th. This is a significant shift in the reported mean value for exactly the same signal. So, what is causing this shift in value? Let's take a closer look at these two different ROIs. What you can see is that the circular ROI fits within the square ROI, and both are, of course, measuring the signal. However, there is greater background pixels in the larger ROI2 than there is in ROI1. And this increase in the number of background pixels is going to reduce the mean of the overall region of interest. So this is a variability in mean radians that will happen if you use different size ROIs. And this is a fundamental weakness of using mean radians to report your data. It's susceptible to any change in the ROI size that you use. Okay, now there is a secondary aspect of doing empirical analyses that makes mean radians less than ideal. Okay, and I'm going to demonstrate this as follows. We'll get rid of these two initial ROIs, and I've already previously created a set of head ROIs for all 5 mice. Okay, and again, what you're seeing here is a number, and then the total photons per second designation per ROI. Now, imagine, if you will, that we are reporting in mean radians. Let's take a look at each one of these ROIs. Is there a difference in the amount of background pixels in each one of these ROIs? Absolutely. The signals are of different size, even though the ROIs are exactly the same. And let's just eliminate the possibility of a second investigator doing different size ROIs. The amount of background area in each of these ROIs is different. So we're differentially affecting the mean of the signal because the amount of background is different between the ROIs of each mouse. So this is a secondary analytical source of variability in mean radians that will add variability to your data that simply isn't there biologically. Okay? And all of this, the variability that you get in mean radians for using different size ROIs, the variability in mean radians that you get because there's a different ratio of signal to background number of pixels between mice, all of that is very neatly avoided when you report your data in terms of total photons per second. So, in summation, as we started, the best units to use when quantifying your bioluminescent signal data is total photons per second. Thank you for your attention. And here's to great imaging.